Okay, so, all right, in order to be able to do this lesson, we are factoring special cases. So I want you to put factoring special products or special cases, okay? And if you remember back to when we learned how to multiply, we had a multiplying special cases, right? So there are two special cases. The first one is called, do you remember the difference of two squares? Yep. And the second one is called a perfect square trinomial. Okay? You may remember the names of them, but we have to kind of delve a little deeper into remembering what they actually are. But the most important thing that you see is that they both involve square numbers, right? Okay? So, remember the square numbers. 1, 4, 9, 16, 25, 36, 49. We don't have to keep doing them, but 64 and 81 and so on, right? Those are the perfect square trinomials. So, the main difference between the two, and please listen because people are really getting them confused. They're thinking of one and then they're doing it the other way. Difference of two squares is when you have like 4x minus 5, 4x plus 5, right? But a perfect square trinomial is if you had 4x minus 5 squared, meaning 4x minus 5 times 4x minus 5. Macy, here's your pass when you're ready. I don't want to keep you too much longer. Okay? So the difference, I want you to think about this. The difference of two squares means the signs are different. Okay? A perfect square trinomial is when it looks like this. And you know that this just means 4x minus 5 times 4x minus 5. It just means they're two of the same, okay? So let's kind of go back and distribute this out and see what happens in the difference of two squares, if you remember, okay? You end up getting 16x squared, a positive 20x, then a negative 20x, and then that negative times that positive is a negative 25, right? So you can see both of those square numbers right there. You see that your two middle terms cancel in difference because when the signs are different and the numbers are the same, they're 0. So your final answer for this is just 16x squared minus 25. So in order for it to be or qualify as a difference of two squares, I want you to put a couple little check marks here. So both terms must be perfect squares. One of those numbers. And the sign in the middle must be a minus, right? Middle sign because that's what difference is. It's a minus. Okay? So if I were to ask you to turn around basically and give you this instead of multiplying it, we're going to go backwards. I'm going to give you the answer. I'm going to say 49a squared minus 81. What two binomials did I multiply together to get that answer? So the first thing you do is you look at it. Does it qualify square number, minus? Okay? If it does qualify, then you make your two parentheses. And watch, this is all you really do. You just say, I'm taking the square roots of each of these numbers, right? So what did I multiply by itself to get 49a squared? 7a times a 7a. What did I multiply by itself to get an 81? 9 and 9. And that 81 is negative. And the only way to get a negative is if you multiply a positive times a negative, yes. Okay, does that make sense? there's a little confusion. I'm going to come back to this column in a minute, but we're just going to kind of keep going on the left-hand column in your notes. Go ahead. So there's a little confusion sometimes of what to do. Somebody want to shut that door for me? So like 40, let's say 64a squared minus 100b squared. So when there's a second variable there, it doesn't do anything. It shouldn't throw you off at all. Is this a square number? Yes. Is this a square number? And is that a minus? So that's the first thing I do, because it might not be that. So then I factor it into the square root of each of these. I'm not going to do this every single time. So I multiplied, and this has got to go over the whole thing, an 8a times an 8a, a 10b times a 10b. That's the only thing now that if there's a b in the last term, then you have to put it in the second spot with the other term. And positive times negative, right? Okay? So, thank you. Trade you. So if I were to look at this problem and say 196x to the fourth minus 225a to the second. Okay, I know the numbers are a little bigger, but if we look back in your original notes, we went this high. Okay, square number. Okay, well, first of all, let's talk about the difference between this 4 and this 2 right here. Do you remember me saying that what types of exponents are perfect squares? Evens, right? Because x to the 6th is x to the 3rd times x to the 3rd. So this is 14x to the, what did I square to get 196x to the 4th? 14x to the 2nd, right? So that can be in your answer. So be careful. I put a few of those on there, of those exponents that are greater than 2. So you have to know that to get that 2 plus 2 is 4. And then you have, this is just your 15a, and then 1 positive times 1 negative, because that's the only way to get that, okay? Perfect squares are really not that bad. So try this one right here. 36x squared minus y squared, just y squared. So go ahead and factor that. What is the coefficient of y? 1. 1's a perfect square, right? So step 1, does it meet the criteria? 6x times 6x, positive y times negative y. Yes? Okay. Now, there's going to be a sheet that I give you where they're all going to work out. What if I give you this one? 81x squared plus 25. Remember back to what I said about in order for it to actually qualify as a difference of two squares, both terms need to be perfect squares. Check. But the middle sign must be a negative, and it's not. So if you ever encounter this, I go back and forth with this every year. There's a little, on the computer program that I use to create your worksheets, there's this box there that gives me tons of options. It says how big do you want the numbers to be? How many terms do you want? Do you want a second variable? And then there's a little box that taunts me every time, and it says, include non-factorable problems. And what that means is the answer, the problem as it's given, isn't factorable. So imagine, like, every year there's kids, when I include those, that'll come up and they'll be like, oh, I tried every possible way I could think of it, I still can't get it to work. And then I have to turn around and say, oh, because it's not factorable. That's frustrating, right? And that's annoying. Okay? I'm not going to do that to you. However, you need to know that those types of cases might exist. That is not factorable. Okay? So, and it doesn't qualify because of that little plus sign right there. So you would just put not factorable. Okay? This is another example of something that's not factorable. Where are we at? 16a squared minus 12. Why is that not factorable? Yeah, because the main rule is that both terms have to be square numbers. And 12 is not a square number. So, and you can put here not factorable because plus sign. Here it's not factorable because 12 is not a square number. Okay? So are you good on difference of two squares? Okay? So here's how you kind of recognize difference of two squares. It's the only binomial I'll ask you to factor. Normally, you're factoring trinomials, right? So all these trinomials here that you had to factor, 2x squared, this, normally they're trinomials. If it's a binomial, first thing you're going to do is say, ooh, there's no middle term. I wonder if it canceled. And if it meets this criteria, then it's that one's a plus, one's a minus, okay? Ready for the other one? Back up to the top for perfect square trinomial. This one's a little more involved. All right? And if you remember this, we'll do this out long ways. So let's say 4x minus 5 times a 4x minus 5. Okay? When I first introduced these to you, I said, just go ahead, box it out, double distribute, do what you're going to do, because I wanted you to see the pattern. And when you did it, you got your 16x squared, right? You got your negative 20x, and then you turned around and got another negative 20x, right? And then what was the end sign always, did I say? Always had to be a positive, right? Because that negative times that negative is a positive. And even if they were both positives, that would still be a positive. And then these didn't cancel. There were two of them. So you said your answer was 16x squared minus 40x plus 25. And then I said to you, do you guys want to know a shortcut that you don't have to, show that step? And so the answer was this. Do you remember me doing this? And I said, you're going to just do the 4x times the 5 and then the 4x times the 5 again. So why not just do it right straight from the problem? So what is 4x times negative 5? And what do I get when I have two of those? That. So do you remember, and there's some people who said, that's too confusing. I'm just going to do the box still. Or I'm just going to distribute still. Okay? It's really not very tricky. It's a shortcut that I want you to try to utilize. Okay? So if I said take 6x plus 4 and square it, my hopes were that you were able to say, let's look where the 16x squared came from. Came from the 4, the 25 came from the 5, and the 40 came from this. So you're going to have a 36x squared, right? You're going to have a positive 16, right? And then this is 24x doubled is, okay, good. That's important to know because now I need to do this with you. I need to give you the 16x squared minus 56x plus 49 and ask you to factor it. So let's stop and think about that. There are some criteria that needs to be met in order for this to qualify. Same, this time both end terms must be perfect squares. Okay. What is the other must? So in addition to both end terms having to be perfect squares, the end sign must always be a positive. Every time. And then this last one's kind of tricky to word. I'm going to try to think how I say it. So to see if this is actually right, okay, because there's got to be one more step for you to go ahead and factor this. Okay, so watch. Because that 56, I don't know. I don't know if that's right. How do you figure out if you're right? You take the square roots of each of these, you multiply them together and double them. So take the square root, multiply them, double them. Watch what I mean by that. The square root of 16x to the second is? The square root of 49 is? 7. Here's a huge, huge hint. Look at your middle term. Whatever is the sign of the middle goes with the, oh my gosh, better get that taken care of right now. Thank you. Whatever sign is in the middle goes in the middle. You understand what I mean? So the middle goes in the middle. Okay? So now, let's check it. Once I pulled these perfect squares out to check it and see if it's right, multiply them together. What do you get? Negative 28. What do you get when you double them? Negative 56. Okay? So, let's say the square roots times each other and then doubled must equal the, okay, that's a lot to write, it's a lot to think about, but go ahead and get that written, and then just read it. Read it after you get it written and think about it if it makes sense to you. So when you have what looks like what might qualify for a perfect square trinomial, square number, plus, okay, I'm going to check it now. The square root of this, the square root of that, multiplied together and then doubled, is my middle term. That's not always going to happen, though. So let's keep going on this example. So let's do one that actually, that does work. Okay, so I want you to try this one. 16a squared plus 8a plus 1. I want you to see if it meets the criteria, and then if it does, see if you can factor it. See if it actually is factorable. So it meets the criteria, 16, 1, with the plus sign at the end. Okay, I just got to check and make sure that 8 is legit, right? So this is a 4a. Square root of 1 is 1. The middle sign goes in the middle. And now I just check it. 4a times 1 is 4a. Doubled is that. Yes. So then if that works, then that is your answer. 4a times 1, 4a plus 1 times 4a plus 1 is that, okay? So what's going to happen when we get to this problem? Let's try a squared minus 15a plus 25. Okay, try that. Looks good, doesn't it? But then when you really, that's okay. That's a square number. That's a square number. That's a plus. So you put your a, you put your minus, you put your 5, but you're not done. You have to see if it actually does factor to that. Okay? So what is a times negative 5? Negative 5a. And if I have two of them, does that give me a negative 15a? No. So this is not a perfect square trinomial. All right? This is something you will use if we ever end up getting to Unit 8. This is a perfect square trinomial you'll see a lot. So make yourself familiar with it. Okay? So try this one. 9a squared minus 14a plus, let's say ab, plus 4b squared. Okay? I want to talk about what happens when there is a second variable there. All that means is this, guys. Look, if you're going to take the square root of this and the square root of that, if the square root of 9a squared is 3a, then the square root of 4b squared is 2b. That's all. It just means that that's in your answer there. And then this minus goes here. So check to see if that's true. That's 6ab doubled is 12, not 14. So this is not a perfect square trinomial. Okay, let's try... Oh, and then let's take a look at this one. Like, what if I had 49a squared minus 16a minus 36? Is that a perfect square trinomial? You know right away why not. Because the end sign is not positive. Not. Because must be a plus. Understand? Okay. So here's what you're going to do. You're going to be given this sheet here, and on 1 through 20, there are 10 of each. You have to be able to look at them and say, is this a perfect square trinomial? Or is it the difference of two squares? Listen to the names. A perfect square trinomial means there's three terms. The difference of how many? Two squares. Like, it couldn't be any more, and it's a difference, so it must be a minus, okay? You are going to have some with second variables in that spot. Just the square root of 100y squared is 10y, right? All of these are factorable. They will have an answer, okay? However, when I give you this sheet, you're going to look at this sheet, and this is a little different because you don't have to factor these. Because, in fact, some of them can't factor. So you have to look at which ones don't meet the criteria. So you're going to look at this and say, x squared minus 24. Yeah, it's a binomial. Yeah, it's got a minus in the middle, but 24 isn't a perfect square. So you're going to cross this one out. Okay? Does that meet the criteria? Square number with a plus. The square roots of each of these doubled or multiplied together and doubled, so that one stays. So you're going to go through the polynomials, identify the ones that actually are factorable. If it's not, scribble it out. The remaining words will give you a little joke. Okay? So, perfect square, or is that a perfect square? This is a tricky one. Is there any number you can multiply by itself to get 2 that's a whole number? No, not factorable or not a perfect square. Okay? So you understand what to do? All right, so you're